thank you for Alex's introduction, and thank you for all you guys coming. I don't expect that because it's kind of like this workshop is kind of like pop-up workshop. Is the notice is really short, so I don't expect like that many people. But anyway, so today I'm going to present something related to statistics and machine learning with R. But basically, we will talk more like about R instead of like statistics and machine learning. But I mean, like it's just an application of R. First of all, I would like to tell you that like all of you will already received the handout, but I just remind that like just don't read it because we will do the exercise together during the workshop. So just don't read it because all the solutions is inside. So and I also would like to ask a question: like, how many people have a background or have a knowledge in like programming? Anything programming? Okay.
A long time ago.
Okay, fine. So many of you do not have any experiences programming, right? Okay, but never. Don't worry about that because like today I will give a really short intro, really like brief introductions about R, which is a programming language, and I will like give you step-by-step introduction so that you will know how to use R also. So I will talk about 4 things today. First of all, I will start by why should we learn programming at R, especially in academia. So why do we need it? And also I will talk about like which is the main part of today's workshop as the introduction to R, and also the data model. Like we will use the data model to process our data and also like analyze it, and also visualize it. And also, I will like touch a little bit about like why should we care about the big data, and also the introduction to machine learning. And most of the content today we will focus on the first 2 parts, and like I will just touch a little bit on the last 2 parts with exercise. So we will doing the exercise together. So I hope that everyone will get a computer so that we can do the exercise together. So first of all, why should we learn programming and R? So as the Google's chief economists say, the ability to take data, to be able to understand it, to process it, to extract value from it, to visualize it, to communicate it, that's going to be a hugely important skill in the next decades. Which means like in this era, like an analytic skill is really important to us, not only at the professional level, but also for the college kid, and also even the like primary school and also the high school kids. And because now we already have essential, like we already have many data. So what we need to do is to try to understand the data and then extract the value from it. This is what the theme of today. We're trying to understand the data and then extract the value from the data. So why programming? First of all, maybe you are asking why don't we just use the SPSS or SAS or other like statistical software instead of programming? And I would argue, first of all, we need to like for academic-based practice or also like open science practice. First of all, we need to have the reproducibility, which means like we have to reproduce the results when we get data. So one thing like SPSS or SAS or other statistical software, or one problem is that like most of this software do not have the comprehensive package to also do the pre-processing of the data. Most of us probably pre-process our data in Excel or other like Excel like software. But R or programming can like gather all the process together, and then we can just like work on all the procedure in one programming language, and then which ensure the reproducibility of the data and the results. And the second thing is like automation. Why automation is so important? Because like for example, like SPSS is basically a manual or click-based software. So when you like come to the data, you click and click the menu and then do the analysis on it. And then it's sometimes quite easy, especially the method is not that hard. But when you're using a really difficult analysis methodology, or using a repeat measures, or you just want to focus subgroup of your data, you need to repeat your clicks all again. And the programming can help you to release this kind of burden. Automation can really you can really use programming to automatically run the analysis, pre-processing, and also the results, and also the graph together in programming. And most importantly, what I think is programming can help us communicate with each other. And because when you get a result from your student, for example, they run an analysis for the data, and then they told you that the result is like that. Okay, but when you ask him how can you get this result, he probably have the problem say, or probably he needs to show you the steps in SPSS to show you how they get the results from it. But programming can also release this kind of burden as well, because you can just read from scripts to know how. Also, you can run the analysis by yourself on your own computer to know how the results come from. And also, it is also important that you can also know other researchers and other people how they get the result from their data, or how they get. And also, we have to communicate to review or give comment to others' methodology. So when you know how to get the data, sometimes I know papers or literature can give a detailed description of the methodology, but still sometimes it's really really fussy and messy, and you don't know how to get the results like this. So it is very important to have a script, or using a programming script to describe the process. So when you read the scripts, you know what exactly they did for their data, and they get the results. And so programming language has different kind of language, but why R? I mean, of course, first of all, R is free and open source. Open source does not necessarily imply it is free, but I mean, for this case, R is free. And it is very important because if you need to buy SPSS, it costs for a student, it costs 55 euros or 60 USD for a license. And it is quite expensive for a student actually, but R is free and R is open source. And open source means another thing as well. It means everybody can contribute to the R programming. So because everybody can contribute to the programming to this kind of language, and so we also get a huge community support, especially R, because people in the academia and also in research, they always most of them use R to conduct their analysis. So therefore, you can always, when you encounter some kind of questions or problems, you can also find a solution online, because people may already encounter some certain kind of problems or difficulties already. So you can look for the solution online. And also, a huge of people using R means that they will also contribute a different kind of update or up-to-date package or statistical methodology to the R community, which you can also use it in your own project. This is something good for you, because as you know, you may know classical statistics t-test and ANOVA already developed in 100 years ago, but nowadays people are talking about machine learning and also different kind of algorithm that can help you to analyze data. But I mean, this is something new, and SPSS does not have the implementations of this kind of new algorithm. But R already have it because people already program it and then put it online. So you can just download from the internet. And also R is a scripting programming language which gives you the advantage of what I say about communication and also the reproduction and also the automation stuff. And also R is highly flexible. You can customize anything you want, anything you need. And also it is highly extensible because it is a language. You can just write anything, any function, any new algorithm, and then implement in your own project. And also it's big data environment, which is quite important nowadays, but I will also talk a little bit in the later part, so I will just leave it here. And most importantly, I think R is available on Mac, Windows, and also Linux. It means that everybody can have the same platform to run the analysis, and this can reduce the errors from the systematic level. But I mean, there are also other language, programming languages like Python and also C++, etc. But I mean, R is the only language specifically written for the statistic purpose. So for today's talk, so R is quite suits our needs for the analysis. According to a surveys from Kaggle.com, Kaggle.com is a platform for practicing data sciences. So many people who are really interested in big data and also who are data scientists will go to this website. They have lots of data set you can practice online there. And then they did a survey last year, and they checked how many people using which kind of tools in their daily practice. Actually, R is ranked number 2 from all other kind of package or software. Python is the top, but it doesn't matter because some of the other survey have different results, which is R is the best and the Python is the second. But, I mean, this highly depends on the community. But I mean, one more important fact is for those data scientists, only really a few people using SPSS, but most of them using R and Python. So this is important because nowadays people tends to using tools like R or Python to analyze their data. So now we're going into a more practical part of today's workshop, which is the introduction to R and the data model. And then we will do the things analysis together. And so I will try to be make the talk more interactively. And so just ask questions if you have any questions. So first of all, I think that most of the computer here is already pre-installed the R. But what I need you to do is to install the R Studio, which you can find on the www.rstudio.com. And for those who are using their own computer, you can also install R on your computer. So first of all, you can download R here in the rproject.org. But what I need you to do right now is to download the R Studio because R Studio is not on your computer. So go to rstudio.com and then go to Products, and then go to R Studio, and then you can download the R Studio desktop here. So anyone can follow it. So if you have question or problem, you can just raise your hand so I can help you.
Desktop.
Yeah, R Studio desktop. So download the R Studio desktop and then install it on your computer. And then after it looks like this. So click here and then get the Windows and save it. And then click run so that I already installed it, so it has this message. And click run, and then you will get the RStudio. So, right. So, does anyone has any problem? Have any problem about installing RStudio? Okay. So, why do we need RStudio? Because R is not an application, but it is a script programming language. So basically it is not an application. It does not have any interface. So when you run on it, you need to run it through the command line. But I mean, it is kind of disturbing sometimes. So for me or for most people, they will always suggest using IDE, which is the interactive development environment, which is the RStudio, which they integrate everything you need in one interface. So including the console, the terminal, and everything you need to do your development of the script. And RStudio is also free and open source, which is quite good as well. So when you open up the RStudio, you look like this, or a bit different. So please open your RStudio, and we will do the practice on RStudio together. So on RStudio, you will basically see 3 or 4 windows inside the interface. So if you cannot find, probably you will miss one Windows on the left-hand side, but you can just click this button, which can open all 4 windows on your interface. So basically, RStudio contains the text editor, which it does not run anything, but more like a text file. You can enter anything you want, and also the console, which is the command line. You can use it to give the command using the R language. And workspace basically it tells you about the variable you have, the detail you have, and also the path, and also everything like Google environments related to variable. And also we have a window related to files, help, and prompting window. So basically it will give you the output here. So you can see your plot or other things in this window. So now we're going to some basics of R. R basically can act like a calculator. So what I need you to do is trying to enter some simple operations in the console window, which is in this window. You can see there is a little arrow here. So we will just try, first of all try to enter 14 plus 3, and then click enter. So probably the window will also return you results of the. So here is the console. So basically you return. So as you can see here, when you enter 14 plus 3, you will give and then click the enter. The terminal, the console will give you back the results, which is 17, right? So I will also why not also try the following operation as well, and then see if you can get the results correctly here. The second one is like 10 divided by 12, and then third one is like 3 times 18, and then the last one is like 3 with the power of 3. So it will probably give you 27, right? Okay, so it is, as you can see, like R can work like as a calculator, so you can do any mathematical operations on it. So it is very important because like it means that you can also do the math on it as well, and then you can also program anything related to mathematics, which is which includes statistics as well. And so, but I mean, like for more complicated operations like log algorithm and also the square root, we can also use the log function and the square root function to get the results. So basically, it is a function. I will also describe what a function is in the later slides. But first of all, let's try log with 36. So log 36 will give you 3.5 something, right? Anyone? Okay, cool. And also try the square root of like 39,204. It will give you a number like 198, right? Okay, so it's really simple one. And besides that, besides like mathematical operations, R is also like the R function also allows you to check the logical statements. And for example, like you can check whether like 2 items, whether they are equal to each other or not equal to each other. But we can also check whether like they are greater or less than each other, the other one. And also we can use and or not for the variable. And now, so what is the output of 50 equality 50 plus 1? Can you give me the answer? Anyone? False, right. So what if I change the equality to inequality? Yeah, you're right. So basically, like this kind of logical statement can check the statements before and after the symbols to check whether they are equal or greater or not. Okay. So I will also like introduce you the R basics about the objects. R basically is an object-oriented programming language. So basically, like within R, there are 2 objects. One is data, which it is used for information storage, and the other one is functions. And functions will add on data and then give you results, or if you anything you script on. So for example, here, the first one, my height is. So you can see here is assignment operator, which is the right arrow with slash. So when you enter my height is assigned to 177, it will not return anything. So basically we just like this. But look at the window here. You can see there is a values pop up, which is my height equals 177. But in your console, it will give you nothing, because you just install this information to this variable 177. But you can also do things like this. So you can also do things like this. You can add a lot of variable here into one, a lot of values into one variable. So C means like combine or like concatenate. So you add all these values into one variable. So when you add this to your console, you will see there is another values for height.people, including which is the number. It means this variable is a numeric number. Numeric variable contains 4 numbers: 177, 156, and 189, and 200. Right? So, and also you can add other variable like my weight. And so we have this kind of information, my height and my weight. And then what we can do, we can calculate my BMI, right? So basically BMI is a function. We have the function add on data. This is my data, my height and my weight. So we have the BMI function to calculate based on my height and my weight, but it will probably get nothing because we do not have a function like this in the current ARC terminal. So we will construct the BMI by ourselves. But first of all, I also describe what the data type or data class in R. R basically contains 4 data classes. The first data class is vector. So basically it means like the same type of data containing one variable. For example, like names, you can enter names is assigned to C, Peter, John, Mary, and Kate. They are all strings variables. So when I copy this to my terminal, so you have the names Peter, John, Mary, and Kate. Alright? And how do we check the class? We can just simply type the class and then put the names inside the class function, and then you will return the type of the class, which is the character. Okay, we also add the IQ score to the terminal. And now we have the IQ scores contain 4 numbers, which is the 100, 125, 143, and 165. So here. So basically all the values are numeric. So when you tap class IQ dot scores, it will give you numeric. So it means like this variable is a numeric variable.
Excuse me, can we have the PPT so that we can also try to
Yeah.
by ourselves?
Yeah. Yeah. This actually you can see in your handout. Just you can look at the handout. The first page is in the sections of our basic data, page 16. I have all the script on it. So now we are going to try the list. So list means like it combines different types of vector into one variable. So basically we can add up the names and the IQ scores together to form a list, so that we have a list containing names and IQ score. You can try it on your terminal as well, and then put that names.iq is assigned to list bracket names and IQ.scores. So you can also look at like what the variable names.iq can give you. You can simply type names.iq and then click enter. So basically it will give you a list with a number indicate 1 and 2. The first one is the names, including Peter, John, Mary, and Kate. And the second array, including the IQ score, which is the 100, 125, 143, and 165. All right. Yep. And the third type of data class is the matrix. Matrix is really special and really important in the statistics, because basically many statistical function is run by matrix. For example, like regression model, and also machine learning regression model as well. So matrix is something important because it gives you the row and the column attributes of everything. So you can locate any single data point, and also you can see there as an indicator of the row and the column attributes. So first of all, we can enter X upper capital is assigned to matrix, IQ score, and row means number of rows equals to 4, and number of column equals 1. So the X will become a matrix. You can check class X. So it will give you a matrix. And I would also like to ask you to try class smaller letter X as well.
What's the difference with small?
Yeah.
The smaller or the big letter?
So I would like you to try both. Okay. After you define the X, it's assigned to matrix, IQ score, and row. So does anyone already try the X, smaller X as well? Okay, so what is the return result? Again? So when you define upper capital X is this matrix, you will give this result, right? But when you put the small letter x, it will tell you the object x is not prime, which means actually in the capital or the cases of the letter is important for the R language. So you should not mix up the capital X and the smaller x in the language. Alright, so we will talk about another important thing in R, which is the data frame, which is also the table. And so first of all, I need you to enter df. It's assigned to data.frame, names and IQ scores, with a comma between the names and IQ scores. So when you enter df, which is the short form of the data frame, normally the people like to use this to indicate it is a data frame. And when you put df into the terminal and then click enter, you will get the results of a table which the table names is names and IQ scores. And also with the row indicator 1, 2, 3, 4, the first row is the Peter with IQ 100 and John with IQ of 125 and Mary with IQ 143 and so on. So anyone, does anybody get this as well? Okay, good. So we already know like the basics of the data. So it is quite important because like basically the R script is formed by this kind of data in the script. So and now we will talk about another object which is the functions. Functions in R contain like two types of functions. They either come from function written by others. So basically it is the package written by others. You can just download from the internet and then install onto your computer, and then you can use the functions by loading the package. And I will also like tell you how to do that in the later slides. But the other thing is the user-defined functions. Basically, it is the function written by yourself. So the basic structures of the function is the name of the function is assigned to a function. Okay, with the argument. Argument basically is the input variable, the input data of the functions, and then here is expressions, means like how do you want to do with your argument. So for everything for anyone learning programming, the first thing is learn how to print the hello world. So we will also do that as well. So the greeting is the name of the function. It's assigned to a function with no argument, which means like you do not need to enter anything. And then this function will do print. It's a simple print function to the terminal. Hello world. Remember that like if it is a string, you need to use a double quotation. It means that it is not a variable, but simply a string. Okay? Print hello with a close big brackets. And then now you can try breathing with empty bracket. So it will give you hollow, right? Alright. So now what I mentioned already, so first of all I need you to create a function that will calculate BMI. And so we will do it together. And first of all I would like you to try first and try to construct the functions to calculate the BMI. And after finish your first function, actually I already give the solution inside the handout. You can check it in the handout. And so first of all, let's try by yourself first. So I already add a function called BMI here. Just give you the equation of BMI in case you do not know that. The BMI is calculated by the I also forget the function. Yeah, by the weight divided by the power of 2 of height. Remember that the height is using the units of meters instead of the centimeters. So finish. All right. So let's try together. Mine is a longer version of BMI, so you will also give something else instead of simply the BMI solution. For example, people who have height of 1.8 and then he weighs, for example, 70 kilometers. And the result is 21.6, which is the BMI. And your weight is normal. That's great. And what I did in my function is, you can also check using the, you can just enter BMI without anything. It will show you the function here. So this is something why I said R is highly flexible, because beside the functions of BMI, I print the BMI after getting the results. I also check whether BMI is within a certain range, which also gives you the message whether you are underweight or overweight. So the if function here means you can check whether if this condition is fulfilled, then you do something. Else if means if statement is not fulfilled, then you also check the else if statement, which also check the BMI whether it's greater than these numbers but less than these numbers, and then you print something. And then else if, and then the last one else means print that is coming to you. Basically means that you are really overweight, and and what you can do I mean, our function is quite flexible. You can just enter anything you want. Besides the normal, like maybe someone will argue that why don't I use the calculator, because the calculator can just calculate the BMI for me. But for programming, actually you can really like do something else instead of just give you a numbers. But also we can also print out the things like print out message related to the results you get from the functions as well. Okay, second thing is I would like you to create a function that will print the sum and products of two integers. So this is something not difficult. And then if you finish this one, can you also try to create a function that will given a vector will print by the screen the mean and the standard deviation, and also it will optionally also print the medians of the vector. Remember, vector can contain more than one numbers. And I will give you a hint here, as you can assign a logical argument in the function, which allows you to print or not print the median. So for the mean function is basically mean bracket with something inside, and then standard deviation is the function of standard deviation is SD, the initial of the standard deviation, and then bracket something. So if you do have the difficulties about like constructing a function, you can just check the handout. I already like include the solution in it. So what I want you to do is basically grasp the logics behind the functions, how we write functions, and how we can like make the functions work in a way we want. Some of you may have the problems using the console to enter the things and to construct the functions. So probably you can construct your functions on the here in the text file first. So for example, yeah, I'm sorry that I do not tell you. Sometimes the space here and the second line here is important. For example, like this function, which is the solution of the challenge questions. So basically, it is a function a and b, product of two integers, and then it need to add a curly here, curly brackets here, and then you need to open a new line, and the sum is assigned to a plus b, and then you can also enter another line, product is assigned to a times b. And then basically you do not need these things. So, and then you can print out the sum and products here. So some of you may like enter all the stuff in the same line, which will cause the problem because you need to clearly define, because you need to clearly let the program know that you already end for one command. For example, sum is assigned to a plus b. If you follow by the product is assigned to a times b, then the program does not know that whether you already end your functions. So you need to stop the this line product is assigned to something into a new line, in a new line. So, and then because you can just copy these functions into the console and then press enter, and then you will get the new functions here, which call results. Okay, and then now you can use the results to do things on the so you will give you the products of 3, the sum of the 1 and 2, and then product of 1 and 2. And then you can try to, for example, try the numbers 5 and 10. So it will also give you it will give you the sum of 5 and 10, which is the 15, and then the product of 5 and 10, which is the 15. Yeah. So remember that start a new line for a new stuff. So you can look at the solutions for the questions exercise here and see if you really have any questions you can just ask me. And so when you look into the handout, for the solution of the a bit advanced level, you can see that I default print.medium equals to false. You can check it. And that is the default settings of the functions, which means like when you enter result 2 with a vector, it will not give you the medium printing. But when you want the function to print out the medium as well, you need to specifically let the function know that you want to print the medium, which you need to specifically tell the function print.medium equals to true, so that the function will also give you the medium printing as well. So I think I will move to the next sections. So if you still have any questions, we can just discuss later. So I will just introduce the data model for the analysis of the data. And I think like it is quite common for people to, especially people working in academia, we always need to tackle the data and then do the analysis on it, and then do the publication on it. So what we need to do actually is from data processing, from getting data and then do the data pre-processing, and then do the analysis and then visualize it, and then make it as like printable or like publishable figures or tables for the people, for the journal. So the data model actually just describes the process of everything you need to make the raw data to communicatable table or figures for people. So basically, you can see there are several important items in the model, which including the import, which talking about the importation of the data. Tidy, which means we clean the data set. and transform the data table into any table you want for the analysis. And then you visualize the transformed table, and then get the concept insights of the data, and then run the model. For example, regression model, linear model on the data, and then get further insights. And then see whether we need to conduct extra or additional analysis for the data. And then we repeat the process until we can get to, and then we get some kind of a result from here, and then use it for computation. So we will talk about each items step by step. But first of all, I need you to install a package called Tidyverse. So Tidyverse, So Tidyverse is a package, a collective package, include Surface basic package, which allow you to manipulate your data and then do the and then tracking the data and also transform the data you want. So first of all, you need to install .package Tidyverse, and then you will download something on your computer. So I will also do that as well because it's computer is something for me. So because I already have this package on my computer, so it will show me updated loaded package. So I will just keep. So for you guys, you need to use this script to install the package, which we will need in the following sections. Yep. So because based on data model, so based on the data model, we have a lot of process to do before we can communicate our data and results, including the import, tidy, and transform, and also visualize and model. So most of the times we only touch on the model, which is doing the analysis on SPSS, for example, and then get the results from the SPSS. But actually what is also important in dealing with data is also the tidy and transform, and also the import of the data. So the package, Tidyverse, containing like other package including the ggplot2, which is used for the visualization, the real for the import, the deploy-r for manipulate your data table, the tidy-r which is useful for cleaning up your data, and typo and per, something like that. So that's why we only. But I mean, like, there are lots of packages, right? So, but the Tidyverse include everything you need for data science. So you can just install this one instead of like install it one by one. So that's why we need to use the install package Tidyverse for the following section. Okay, so now we already installed a package. Now we need to load the package, which we use the library Tidyverse. Library is a function that you can load any package you already installed on your computer. In this case, we load the Tidyverse into your computer. And normally we need to set our working directory for our data, but I mean I will use online data, so we do not need any. We do not need to set our working directory. So now I would like you to read a file called getMiner using the read underscore CSV. Read underscore CSV is a function to read CSV file from these websites.
Just like I try with the dot CSV.
It's also .csv is also okay, but I mean like read CSV underscore is specifically for tidyverse. So .csv is also
Just like I try each one. Every day.
Okay.
Change it to dot.
yeah. I will try here as well. Did you load the?
Okay, by the time I didn't install the package.
Yeah. So first of all, you need to library tidyverse, and then you read this CSV file, and then you can see that like this message, it just gives you the information of the. It just basically gives you the information of the CSV you just read. So including country, a variable called country, a variable called year, a variable called pop, which is the population, and continent, and life X, which means the life expectancies, and the GDP per capita, including, so you can see that like this data sheet containing 6 variables, including country, year, pop, continent, life expectancy, and GDP per capita. And when you want to see like what really a table, you can just use the view function. And so when you type in view getMiner, you will get the table here. So you can see the first variable is country, year, pop, continent, and life X, and GDP per cap. 6 variables, right? Everyone get this? Okay. So, but I mean like this is too long sometimes. I can tell you that when this is a really long tables, you can check the theme. Theme means the dimension of the data table. So it gives you like 17046, which means this data table contains 1,700 rows with 6 variables. Sometimes it's too long, so I just want to see like, for example, few examples of the data table. You can just type in head getMiner. So it will give you the first 6 rows of the table. But you can also use tail, which will give you the last 6 rows of the table here. And if you want to know like which variable names we have, we can also use names getMiner. So it will return you basically the variable names of the table. So for this part, first of all, you need to install the package and then load the package library using the library function, and then read the CSV from this website, and then you can see the, this table. All right. So for tidying, because like the table we are using is perfectly cleaned, so we cannot use it for demonstration. But I will just like briefly talk about like, why do we need to tidy up our data table. For example, like dealing with like NA missing data in the data table. For example, in this case, when you use age with a vector variable including three numbers with NA. NA means missing data or not available in R. And then you use mean age, mean function to calculate the mean of the age in this vector. What do you have from the results? So it should give you nothing, right? So it's basically an error message telling you that you cannot calculate anything from the missing data because like your vector containing a missing data containing a missing variable in your vector, so that you cannot give you any mean of the age. But how do we deal with it? So remember you can either remove it from the age, or you can use the default function of the na.rm default function in mean function, which is the na.rm means remove na when you calculate the mean. It's a default function. The default function of na.rm is equals to false. So when you explicitly indicate it is true, then it will calculate the mean without the missing data. Alright, so now we also, like as you can see from the table, you can look through the table. Actually, the table, the data table containing many different year data time point. For example, we have like 2007, 2002. So for example, if we only interested in the year of 2007, what can we do? So what we can do is we filter only data in year 2007. So what we need to do is like here, we getMiner is the original data set, and then we carry out the functions of filter, and we only need the data from 2007. So when you carry out this command, we will get a new data set called getMiner 2007. So what if we only interested in country from Asia, because we also have the no, it should be continent. Well, from the continent Asia, so it is not the country here. So if we only interested in data from Asia, what we can do? We can just specify filter continent equals to Asia, and then we will get a new data set called getMiner underscore Asia. And what if we're only interested in population large than 10 million, I guess. And we can also using the filter function to specify population larger than this number. So the city I called mega city. So the function name, the new variable name, new data frame name is getMiner underscore mega. Alright, like this name is really arbitrary, so you can just like create any name you like, and any name like you find like reasonable. Alright. Yeah. Anything? Any problem here? Okay. So we will also go into another big part of the which is called visualization. Because human brains process information really visually, more than like reading reports and like texts from or spreadsheets or many complex stuff from the data directly. So data visualization is a great easy way to convey concepts in a universal manner, and that's why data visualization is quite important, especially in publication. You always look at the figures and table first instead of like looking at the texts. So that's why people, and also in the presentation, you also find like a table is more vivid than the texts. That's why data visualization is important. So I will introduce you how the ggplot2 package. So basically, ggplot2 is a package that you can create a lot of different kind of figures. It is a layered function. So it's basically you can create a layer by layer figures using simple command. For example, first of all, I would like to create a figure with the x-axis is the GDP per capita, and the life expectancies for the y-axis. So I can call the function ggplot, and using the data, get minor axis, x equals to GDP per capita, y equals to life expectancy. So you can just enter this command, and then you will get this figure. So you can see like there is nothing, right? So it just gives you the frame of the figure. And then what we need to do now is we add the things we want for the figure. For example, I would like to add the scatter plot for the GDP and the life expectancy. Basically, it just map the points for each GDP per capita to the life expectancy in each row of the data input. So I add plus here. It means I add one more layer of geo points, means the scatter point with alpha level of 0.5. It means like half transparent, and with a size of 0.5. You can also adjust the size to 1 or the alpha to 1. It means like it does not transparent and the size is double. So you will see a bigger So you can see here, when you customize, for example, I want a size of 2 for the geo point. So you can see the point is much bigger here than before, right? So if you also want to indicate the continents of the data point, you can also add the color equals to continent. So it will show you that each data point belongs to which continent as well. So basically, you just need to add one more axis here, which is the color equal to continent, and then you will get this figure. All right. So what if I just interested in the, for example, like the x-axis is the continent, and then I'm interested in like in each continents, what is the life expectancy in each continent. I can just show you the box plot here. So the box plot basically means the median, the mean of the of each continent, and then how they distribute in this continent as well. And you can see here, the Africa has a lower life expectancy than the others, based on this figure. Alright? And you will also see some of the points here. Basically means just the outliers of the data. Okay, so what if I just want to know like the distribution of life expectancies of all people? And you can use the histogram. So using the x-axis as the life experience, using x-axis is the life expectancies, and then I add a genome histogram, and then I can see the life expectancy count per value. So you can see the highest count, the most people who have, like most people have a life expectancy of like 78, and the lowest is like life expectancy with like something 25 here. So basically you can do things like this. And I know it is a little bit challenge, but I will let you try at home because like we do not have much time today. But basically what you can do for R, using R you can like create such a beautiful figures using the script we just used. And to create a figure like this, basically it's a really vivid and also insightful figure. You can see that, for example here, as the GDP increase, you can see the life expectancy also increase as well. And also you can see like some of the figures population and the in the figure also like bigger population also imply that you have a longer life expectancy as well. And then you can see the cluster of the developed countries has a higher expectancy. For example, the yellow dot means the Americas. Here, they have a higher life expectancy than those countries in Africa, which is the red or pink color here. So from one single figure, you can see a lot of like information based on this single figure. So please try to configure something similar at home and try to see whether you can also make a graph like this as well. And all the solution, as I told you, is in the handout. You can also check this in the handout. And now we'll go into the analysis, which is the model as well. And so, first of all, we already have some insight from the figure. And we would like to do the statistical testing on the figures, on the numbers, and see whether they really like differentiate each other based on a statistical testing. So for example, but first of all, we need to do some descriptive steps first. So we would like to know, like for example, the mean or the mode or the median or the what the mean is, what the median is, and also what the mode is. So we can use summary function. It will basically give you all the information you want for the whole data set. So when you use summary functions, So it gives you each variable, the information of each variable. For example, for the country, because it's a character string vector, so it just gives you the class and the mode is the character and character. But we know that there is 1,704 people for a row in the data. And for the year, you can see the mean is, year here is also a categorical data because it just means the data collect from which year. But for population, you can see that it calculates the mean and median of the population, and also the life expectancy, and also the GDP per capita as well, using these functions. But what if you want to know the life expectancies in each continent? You can also use these functions. Using the by functions, you can indicate the index equals to Gapminder continents. So, and using the summary by using the function summary. So it will give you each continent's summary data of each continent, right? And so, what if I also want to know how many countries I have, or like how many countries uniquely represent in the data set? We can also use unique. Then the dollar sign here represent you want to select one variable. So for here is you look at the country variable inside Gapminder. So unique means like how many unique variable in this unique values in this variable. So when you type in unique, you will probably get a long list of countries, which are also shown in the handout. And also the length. So this function will give you a vector. So if you want to know how many variables in a vector, you can use the length function. And using the length function, you can get how many countries you have in the vectors. So so basically, when you type this in, you will get a lot of country lists, right? So, but I'm just interested in how many countries I have. So I can use this function. So the answer is 142. So it means that in the data table, we have 142 countries in the data table, right?
Why do we have 141 countries in this?
I need to check it. Alright. So probably something wrong there. Because oh, you mean here? Here in the handout, you can see an indicator here, right? So it basically set the number of the value in the vector. So it just indicates the first value in which position. So for example, 119 Spain, it means just Spain is in the vector, in the position of 119 in this vector, right? So for example, for this one, Poland, 103, it means like the 103 the position 103 in this vector is Poland, and this one is and this one is 104, and this one is 105, and reunion is 106. All right. All right. So we already have some insights about the correlation, or for example some trend in the figure, and I will also want to know what is exactly, for example, the correlation between the life expectancy and the GDP per capita. So what can we do? And here we can use the correlation function, which is exactly the same in the SPSS. You can run the correlation tests. In R, you can also do something similar. You can just using the command correlation call to find the correlation between the life expectancy and also the GDP per capita. And in your handout, I already print out the results for you. And this is so it will give the results of so when you run these functions, you will get something like 0.5. 0.5. Yeah. So it means the correlation between these two variables has a correlation of 0.58. All right. So what if I want to know about whether Asian people has a longer life expectancy than European? What I can do? So first of all, I need to filter out, or what I call here subsets, data sets containing only Europe and Asia here. So I subset the data into a subdata set containing only the continents in Europe and Asia, and I call it the Gapminder subset. And then I do the t-test here to test whether the life expectancy between these two continents, and to see whether they are different from each other. So when I run the script here, I will get a result here. Basically, you will get a t-value. Negative means that Europe has a longer life expectancies than Asian. And the p-value is really highly significant. And there is an alternative hypothesis, true different, it means it's not equal to 0, which is it denies the null hypothesis with a confidence interval here. And so it is something you can do using R. But also, you can also do the pair sample t-test as well. For example, I want to know what's the difference between the year 2002 and 2007. So first of all, I subset the data, and then using only data in 2002 and 2007. And then here is important because 2002 and 2007 is a number. That's why I need to use as dot factor to factorize the year from numeric to string, so that they are treated as a categorical data. And then I do the t-test using the pair equals true, means that I want to perform paired sample t-types to see whether they are different from each other. So here, as you can see, like there is a true difference between these 2 years, and the p-value is highly significant as well. Alright, so, and also you can do something more fancy. You can do something fancier by using like general linear modeling. Basically, you can add anything we have into the model. For example, like here, LM is linear model, and this life expectancy is predicted by population, GDP per capita, and also year, using the data Gapminder. And more here is the model fit. So I just installed the model fit information into a variable mode. And then I use summary mode to get the model summary. So when you enter this script into terminal, so you will get the information here. You get the residuals, which is the unexplained variance in the in the model. But you can see also the intercept with estimate here, and also the p-value, t-value here, and also the star means how significant it is. And you can see from this model, life expectancy is predicted by population, and GDP per capita, and also year as well. So it means that life expectancy is higher when population is bigger, and also the people generate higher GDP per capita, and also more recent year people are have more higher life expectancy as well. And you can see the model fit of the linear model here has a p-value smaller than e minus 16, means really significant. It basically means the model is significant, right? But we can also see there is information about the adjusted R square as 0.4392. Basically, it is the effect size of the model. The model can explain the 44% of explain the variance of the variables. All right. So basically, you can see the R can also do something similar to SPSS, but in a more flexible way, because I can just call out something. For example, the coefficients of the model. So here, when you use model, I call out the coefficients. I can get the information of the population, GDP per capita, and year here by calling mole $ coefficients. So it is something not available in SPSS, but I mean when you're really dealing with a difficult model or like complicated model, when you're using R, you can use these kind of functions to extract information you want. So I will also leave the exercise for you to carry out at home, but I will also already provide the information and solution in the handout. You can just look at it. So we are going to the final part of the this data model, which is the communication. It's nothing special, but it's just something you need to follow to make the communication better. For example, how about the writing styles of your script? For example, you can use Google's R style guide to guide your styles or for writing R scripts. But I mean, it highly depends on the lab or the working place, the working environment you are in. So it's just references. And also remember all the times you need to add comments. So what is comment? For example, this one is the comments of the script. It does not run anything when you carry out these functions, carry out this command line. But it just means that you describe how this function will give you, what information will give you from this function. For example, this is the model summary from this summary mode. And for example, this is the regression model. You just tell people that like you are running a regression model using this information, right? And also you can use the R Markdown. And the handout I give you is created by R Markdown, but it is something not within our scope today. So you can just imagine that it's something like you create a document with programming as well. So, but you can also include the results in the document easily. Okay, so we will also touch a little bit machine learning and big data today. And why should we care about big data? So, because I have a background from psychology, but I will just briefly talk about something related to psychology, and also a bit more about like psychiatry as well. But I know that some of you come from the business department, right? But I mean, big data is also something really hot and trendy in business field as well. People are interested in my field is nowadays interested in human brain and also human genome, which is will give you a lot of information when you carry out the data collection process. So human brain has a lot of when you scan the human brain using the fMRI and also EEG, actually you get a lot of information because we treat human brain as a 3D voxels. So, and then the voxels is basic unit of the image, or of the 3D image of the human brain. And when you look at the human brain, actually we have more than 2 million voxels in each human brain. So actually when we scan 1 times of the human brain, actually we create a lot of it. Also human genome, for example human gene, we have more than 2 million human gene. It's quite similar to the human brain as well. The number of human genome also gives you a lot of data. But nowadays people are also interested or like they like to wear the for example Apple Watch or like a wearable device, digital device, which also collects a lot of data from it. For example, Apple launched a health app which will record your heartbeats every day, and then they also use heartbeats to analyze and heartbeat data from every user to do the analysis. And this is something we can do in our research as well. And also social network. Social network is a huge, also provide huge amount of data from when you look at the Facebook or also look at the Instagram or also look at the Twitter, for example. So what is the difference between the experiment generated data compared to the big data? For the experiments, we usually have a lot of subjects. N represent subjects, P represent variables. We have a lot of subjects and then we collect a few variables, right? But for big data, we collect a lot of variables, but we only collect comparatively fewer number of subjects from the data set. So this is something different because classical statistics is really specifically tailor-made for this kind of data, but not this kind of data. That's why we need to reduce the features using a machine learning stuff to select the features or variables to do the prediction or do the analysis. So, because I already talked about big data and the why we need machine learning to on the big data, so I will also introduce what is machine learning and why do we need machine learning. And basically, machine learning is you use generic algorithms, which is not specifically written for any kind of like phenomenon or questions you want, and then you run using this algorithm to learn from the data. And also there is a feature that's like more information we learn to higher performance. So the more information you get, the better performance of the algorithm you get. And also the algorithm is always learned from experience, which is the data, but not the preset program of what you want to do in the script. So common ML problem, well, machine learning problem, we have three common machine learning problem. First of all is the classification. Basically, we want to classify single subjects into any kind of groups we have from the data. So classification involves identify the classes, which is the category as well, that a particular incidence or observation belongs to, based on its features. So we have lots of features, and we have a new subject or a new observation. We want to know which of this observation belong to which classes in our data. We can use classification method. And also regression is similar to statistics, linear model stuff. Basically, you can predict from your features the goal is to build a model that you can like predict, do the prediction from the outcome of new data samples. So you have all sets of samples. You learn a new model from the data, and then you use this model apply this model into a new data and then do the prediction. And the last one is the clustering analysis. It's always when you want to see the similarity and differences between the samples. So basically, it is a method to look for the hidden patterns and structure in the data. So basically, it is we can also further like categorize this method into two categories. One is supervised learning, including the classification and regression. Basically, just develop a predictive model based on both input and output data. So you will have the input data, and then you get the input model from the input data, and then apply the input data to the output data.
Can you explain a little bit more on the difference between classification and cluster?
Yeah, classification, you also want to know a new subject or observation belongs to which group or classes.
First you also already have some groups.
Yes.
Is it from clustering or?
Yeah. First of all, you do a clustering, and then you apply the clustering. Yeah. And then you just look at the new observation, see whether this new observation fit into which group of the clustering. Yeah. So basically, sorry, this is a mistake. So basically, clustering is unsupervised learning. So unsupervised learning, you just group and interpret data based only on input data. It does not use the output of the input data to do the prediction. So clustering, the difference between clustering and classification is just a little bit. It's just a step difference. So what we want to know from our data. So basically, statistic can be used to two things. One is inference, and the other thing is prediction. Both statistic and machine learning can do both. Okay, but for inferences, basically creates a mathematical model of the data generation process to formalize understanding or test a hypothesis about how the system behaves. This is what classical statistics would. But for machine learning is good at, is better at prediction and aims at forecasting an observed outcome or future behavior, such as whether a mouse with a given gene expression pattern has a disease. So, so this is, I mean, like the boundary between the machine learning and classical statistics is not that clear, but you can see the machine learning is better at prediction, but the classical statistics are better at generating a model to understand the behaviors, right? So, but I mean, like there is a big data hubris, which people always has the assumption that big data is better than classical statistics or classical or relative small data, or for example, like the data generated in the laboratory, right? But actually, big data or machine learning is a supplement, not a replacement of traditional data collection and analysis. And simply having more data does not necessarily mean that like big data isn't necessarily means it's a better data, right? So I can give you an example. A case of Google Flu trends. So back to like 10 years or 20 years ago, 10 years ago probably, and Google wants to do the prediction of peak season of flu. So they create a system which they check the people searching flu-related items in their browser using Google search. Okay, so at the first of all, they really make a good predictions as the CDC document. Let CDC means the CDC have the documentation of whether it is a peak of the flu season. And actually, when you look at the first year 09 to year 2011, you can see that like the prediction actually is quite good, right? Google Flu can GFT can actually predict the peak season of Google Flu of the flu influenza. Okay, but when at that point, this surveys actually get the attention from the public media. So public media actually like really interested in how good this application is, and then they telling that everybody that's like Google has Google Flu trends that tell you whether now is a peak season or not, or whether like 2 weeks later whether it is a peak season or not. And then people know that, and then they start searching, no matter whether they have flu-like symptoms or like whatever they have, they just like Google editing after they this news is probably is up to the media. And then actually when people know that this can be something, this some kind of predictions for the flu seasons, people will start to searching more. And in the 2012, in the mid-year of 2012, you can see here, the Google Flu actually predict more than the CDC document data. So, but of course they do not think about this factor before they announce this application, right? So the problem is that more data does not necessarily mean a better data, but you know you need to really careful about the data features you collect from the from the samples you are studying on. And here's some take-home message and outlook. And for academic-based practice and also open science practice, R is a good choice. And R programming provides a good environment for reproducible research, which is a really important factor for the open science practice. And learning R can get you ready for the big data challenge. Although the big data is not necessarily big data, you should also really remind yourself that you should also care about the rigidity of the method you're using. And personally, I favor big data for generating novel hypotheses. You can really get some insights from the big data. And then you can carry out experiment for hypothesis confirmation later. So this is something important, and you can always get the resources from the internet, including this CLAN, Stack Overflow, RBlogger, R4Stats, etc. And everything about how you can get the information online, on the internet, and from this community. And that's it. And thank you for your attention. It is really a long workshop, I know, but thank you for your patience. Thank you. I'm happy to take any questions, so if you have any questions, you can just